And it is now recording. All right, so exercise 5.7 for both year levels, you do need to know the skill. When they say 5-number summary, that represents these 5 key points. 5-number summary, first one represents the minimum number, so the smallest score that you have in a data set, which I'll then talk about number 2, number 3, number 4 to make sense out of why we do Q1, Q2, Q3. Okay, so your 5 key numbers are minimum number, then Q1, then Q2, then Q3, and then your last number, so your 5th data is the maximum. Those are your 5 key special numbers, and you can see it on this diagram here. That lower end, that very last dot, that represents your smallest value, so minimum. So just right here, that's your minimum. The very highest end here is your maximum. Okay, and then you can see it's split up into quarters. As you can see, that's the first quarter of the data. So if you think about it in terms of percentages, first quarter is the 25%. Okay, 25% is a quarter of your data. So 25% of the data sits right here, and right up to this endpoint, that's called Q1. Then the next 25%. Next 25%, so from Q1 to the middle part, which is your Q2, or they also call it the median, which is why they say it's the 50% tile, because you're right at the center of the data. Then from Q2, so next quarter, so next 25% of the data goes from Q2 to the upper point, that's Q3. So that's what Q1, Q2, Q3 represents, but I'll explain, well, why do we even want to know Q1, Q2, Q3 in a logical sense later. And then finally, Q3 to the maximum, that's your next quartile. So that's your next 25%. So hence, if you add them all together, that's 100%, but you're splitting up your data into 4 different sections. What are these 2 words here? It's the quartile 1 is the middle of the lower half of the data set, whilst Q3 is the middle of the upper half of the data set. Can I get a show of hands to remember what IQR stands for again? Because that's one of the key skills that you'll need to know for both of you. Yep. Yes, it means Q3 minus Q1, but what's the name? IQR stands for interquartile range. So this means interquartile range, for those who don't know yet. The question is why? Why do we do Q3 minus Q1? I know it's what I tell you to do, but let's think about it logically. Why we take Q3 minus Q1? So Q3 is over here. I'm going to highlight it so you can see. This is Q3. Then you minus Q1. So in a way, if you think about it, Q3 is 75% because 25 plus 25 is 50. 50 plus another 25 is 75%. So you're saying take 75% of the data and then minus 25% of the data. So what you're left with is from here to here, that's 50%. So why do we do that? So here's the logic. For those who didn't understand statistics back then, why do we do Q1, then Q3, and then, find the median? Here's the logic. If I told you in our class, if you were to do a study, right? Imagine my class was 100 students. One of the first things you want to know is this a good class? Is Mr. Tran a good teacher, right? You can either interview every single student. Okay, so if I had 100 students, you go to around 100 students and you ask, is Mr. Tran good? Is Mr. Tran good? Is Mr. Tran good? Do you like this class? Is this class good? You go through 100 kids. That's one way of doing it, and you get a vibe, right? Or the most logical way is that you only ask a few of your friends. You might say, hey, who do you have for maths? And they're like, Mr. Tran. You're like, is he good? You might do a sample of about 3 students to 4 students out of that entire group. So the logic is, in reality, when people do studies, they're not going to measure the entire population because that's too hard. So what they do is they grab a sample. That's the most realistic way of doing it. That's why you have those people to come to your doors. They knock on the doors. They ask you to participate in surveys. Or you see the people on the streets where they stop you on the streets. They give you a pamphlet and say, hey, do you have 2 minutes to fill out this information? The reason why they do that is because they're getting a sample. They can't get everyone, but they get a sample. Now, when you get a sample, how much is enough? how much do you generally feel that should tell you enough about the class, right? See, if you only got 3 students out of 100 students, that's only 3% of the data. You can't really rely on those 3 students. So then how much is enough? Now, most people would say about half of you. If you can get half of the population, that's a pretty good data. But here's the problem. If you get half of the people, which half did you get? What if you got 3 of the students in the bottom half? And they say, yeah, Mr. Tran's crap. And they barely come to my class. They might have come once and I said, hey, you're late. And they hated me. Those 3 students say, Mr. Tran's terrible. You can rely on that 50%. But where's that 50% coming from? Right? Or similarly, you could also have 3 students on the very upper end. So again, they might represent the next 50%. What's the problem with that? So they might just like the fact they like school. No matter which class you ask them, they're just like, yeah, Mr. Tran's class is great. It's perfect. Maths is great. But that's not really reliable. So what we do is we say, well, since we want 50%, but we don't know which 50% we're getting, what we do is that we rank them. We rank everyone from lowest participating to Mr. Tran's class to highest participating in Mr. Tran's class, which is one of the first steps. You start ranking 1, 2, 3, 4. So you rank all the data from smallest to largest. Then what you do, you find the middle person, you cut it in half. And so now you have the bottom half of the group and you have the top half of the group. Too low on the bottom doesn't tell you much. Too high on the top doesn't tell you much. But right in the middle of both, that tells you a bit more of the population, which is what this bell curve represents. Because there's always the general group where most people sit, and then there's like the extreme people that are so intelligent or someone who doesn't really care at all. So because of that, there's 2 extremes. So instead of taking the bottom end or the top end, what we decide to do instead is that we say, well, instead of cutting it in half, why don't I cut it in half again? See, if I cut it in half again, can you see the logic? I will still get 50% of the data, but instead of getting 50% on the left or 50% on the right, I take 25% here, and I also take the 25% here. That covers most of the population. It's not the extreme people who don't come to school or the people who love school too much. They're not those people. I'm actually looking for the population. That's why we work between 25%, which is the middle of the lower half. So who's the center in the bottom half? So if I looked at this class, imagine I separated you 2. I said, these group of kids hate school. They don't want to be here. And these group of kids love school and they want to be here. Who's the middle in this group? Who's the kind of like, oh, you know, I don't really like school, but I don't hate it to that extent. And this one's like, oh, I like school, but I don't like school to that extent. If I take that middle person and I take the middle person of this side, and then I just group them, the ranking from left to right, this data still represents 50%, which is what we wanted. We don't want to measure 100% because that's just too many people. I still get half of you, but it's a better data because it represents most of you. Get me? That's the difference. See, I could have done the measure of 50% on the lower half, but I'll include people who really don't like it. That skews the data. If I have too many people on the upper end, they love school so much, no matter what you do, they're still going to love it. So that doesn't really tell me much. But the middle 50% of people, that's the general population. That's a better data. That's what the IQR represents. And that's why we use that as a data to explore. It also is another good thing is that if you have any outliers, those people on the extreme end, whether they're just too smart for school and too unengaged or disengaged, they're not including the data. So the people that really skew the information, who's like really got a biased opinion, they don't skew the data because we're only focusing on the general population. Does that make sense what IQR represents? Yeah, so that's on a theoretical sense. So if you're doing, this is mainly for year 12s now. So year 11s, you didn't, if you get that, great. But year 12s, for you, when you're doing the exam, the examiners will ask you. They will ask you, well, why is the IQR more important than the range? What's the flaw of finding a range versus an IQR? You have to be able to explain that. And hopefully, the way I'm trying to describe it in a scenario, you understand. So the range, smallest to largest, includes the extreme people. But the IQR doesn't, which is a good thing. Okay, that's one of the benefits. So knowing at a year 12 level why you do IQR versus range, that's one of the reasons why. Whereas year 11s, you just need to know how. So the Q3 minus Q1, that's what year 11s need to know. The next level for year 12 is understanding why. Why do I need to know that? Okay, so write your own notes so that you understand that difference there. But for today's lesson, it's pretty straightforward. We're not going to go through, how to draw the box plot yet. We're just going to go through how to find those 5 number summaries. So let's do first example. Here we go. Let's have a look at example 1. For the set of scores below, so I got 12, 15, 46, 9. They're not ranked. Okay, so these, there are no throwing in my class. Get up in a seat, burn some calories, throw it in the bin and come back. That's the way I want you to do it. So now you've got these random sets of data. There'll be some people on the extreme and some people on the bottom, maybe, but we want the majority of the data. So here we go. First step, reorder the data. So at the moment, what's the smallest number you can see? Smallest number? 9. Okay, so I'm seeing 9, so I'll cross that off. What's the next number after 9? It looks like it's 12. Then 15. Then what's the next one? 29, am I right? 29? Yeah, 29. 29. 36. 46, yes. 50. 64. 73. 85. Write that down if you couldn't be bothered writing it from smallest to largest or sending order. I've done it for you. Great. How many data points do we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 data points. Now, I want to split them into quarters. I want to split them into their groups so I know who's the middle, then who's the middle of the lower half, and then who's the middle of the upper half, and who's the smallest and largest person. That's your 5 number summary. Now, smallest and largest is pretty easy. Minimum. Smallest is clearly 9. So this is my minimum. 9's my minimum. What's my maximum? Can I please have, let's go with Michael. Out of data here, what's my maximum number? 85. That's the largest number I've got there because it's all ranked. It's 85. Great. That's the easiest ones to find. Then now finding the middle. Now there was a quick way to find the middle, especially because right now there's 10 numbers, so it's easy to figure out. You need, like 5 on one side, 5 on the other. Does anyone know the formula? Because if I gave you, say, 98, if I asked you, what's the middle position? Do you know the quick way of finding median? Hands up if you know. Archie? Close, but not plus them all together. What's the formula? So if you had 99, you don't want it, or 98 people, you don't want to add them all and then divide them. What is the quicker way to know exactly where the middle position is? Divide the number by 2, but there is one extra one that makes it easier. Plus 1, very good. Write this down if you didn't know. To find the median, if you didn't know, it's actually easier if you add the number of data you have by 1 and then divide it by 2. Okay, so for example, if I had 4 people, so 1, 5, 8, 10, that's 4 people, right? The middle is clearly in between the second person and the third person. So it's 2.5. It's in between the second and third person.
What do you divide again by? 2.
Divided by 2. So what do you do here is you add the number of people. You got 1, 2, 3, 4, add 1, makes it 5, and half of 5 is 2.5. And that's why I know 2.5 is the position of the middle. So n plus 1 will do it for both even and odd numbers. So say if I had an odd number of people, let's say 1, 5, 8, 10, 11. So I now have 1, 2, 3, 4, 5. The middle person is clearly the third person in rank, right? So what's a quick way of doing it? Count the number of people. 1, 2, 3, 4, 5. So 5 plus 1, 6. 6 divided by 2 tells you it's the third person. Does that make sense? So that formula is a quick way for you to figure out the position of the median. Pav.
So it's how many numbers there is plus 1.
Very good. So in this case, I've got 10 numbers. 10 plus 1 gives you 11. So number of people, number of data, we've got 10. Plus 1 is 11 divided by 2. What's 11 divided by 2? Or what's half of 11? 5.5. So what does that mean? It's between 5 and 6. So right here in the data, I can already see that's the middle. That's between 5 and 6. So even if the number was up to 99 and I asked you, where's the middle position? 99 plus 1 is 100. 100 divided by 2 is 50. The person who's the 50th rank is the middle. Or 98. If I said there's 98 pieces of data, you don't want to sit there and trying to figure out where's half and half. You just do 98 plus 1, it's 99, and then divide that by 2. That position is the middle. Okay, me? Now, anyone remember? So it's between 36 and 46. How do I find the middle of 36 and 46? I mean, you can count it, but there's a quick way to do it. Good. That's called the average. Find the average between the two. So if you weren't sure how to find the middle of 36 and 46, I mean, you can count it with your hands. The quickest way is find the average. Do 36 plus 46, add them both together, divided by 2. Remember, you can use a calculator. In this subject, you use a calculator, but only scientific. You're not allowed to use CAS. Yeah? 36 plus 46, what does that end up to? So 30 plus 40 is 70. 70 plus 12, so 82. 82 divided by 2 is 41. So you should get 41. So the middle of 36 and 46 is 41. Okay? So if they ask you what's the median's 41. But in terms of the data, here's the middle. And this is my 5 sets of numbers on the lower half. So these are the people, say, if it was about going to school, these people don't like coming to school as regularly. And 9 is the worst. Right, but I want the middle of those 5 people. And since there's only 5 numbers, the middle clearly is 3. Or you can do 5 plus 1 divided by 2. So Q1 must be 15 because it's the middle of the lower half. So I'm going to color code it for you. So this is the lower half. Out of those 5 people ranked, who's the middle? The 1, 2, 3, 4, 5. So it must be the third person. So number is 15. That's Q1. Middle we worked out. Number 41. So that's the line. Now the upper half, I'm going to color it in yellow. Here's the upper half. I've got another 5 people, 46, 50, 64, 73, 85. And I'm trying to find the middle person of the upper half. Middle person of the upper half clearly is that 8th number there. So you can see, again, that number right there. So 64 is your now Q3. And so answering the question so far, if you were to draw a box plot of this, smallest number is 9, roughly here. Do a dot. So 9. Highest number is 85. So 85 might be around here, so between 90. So here we go, dot. That's 85. And then my next quarter is 15. So by the time I get to 15, which is around here, you do a vertical line. That's the first step of your box. And then where's your next one? Middle is at 41. So 41's probably really close to this one here. So let's do a vertical line here. That's 41. And finally, Q3 is 64. 64 is just less than half. Half is over here. So maybe 4 is over here. That's your quartile. So when I draw the box, why do we call it a box plot? Because that box is the majority of the group. That's the 50% of your data. That's where most people sit. Then you have your tails. These are the tails. These tails represent who's on the extreme. Now, if you just look at this data so far, most people sit between 15 to 64. But can you see the tail end? Which one has a longer tail end? Is it the left side or is it the right side? Which one has a more of a longer tail? The right side. But what does that mean? If the right tail is longer, what does that tell you? Yeah, or there's a few people who have really high scores in the upper end. Okay, it could be one person in the very upper end. We don't know if that's an outlier or not. It could be 2 people up there, but it just means that the scores on the higher end, we have a very high score on the top end, but it doesn't mean that there's a lot of people or anything. We don't know that yet. But what we do know is the lower end, it's not that high. The next bit to compare is in each quarter, remember 25% of the data, 25%, 25%, 25%, and then 25% up here. The question is, does that look equal? Because if it's not equal, that means your distribution is not symmetrical. It could mean your graph looks like this. That means there's more on the lower end. So if I were to compare a school, and let's say the year 12 class, and I see this tail, this might imply I have more students in the lower end for this particular subject. So that's why when you measure it, you got to think about, well, it's 50%, but 25%, 25%. Is it the same shape? Because if it's all the same shape, if it was all equal, then it's symmetrical. Otherwise, what I can see right now is because there's a right tail end, that's probably meaning there's a stretch on one side. And at a year 12 level, you have to learn to explain that. That's what they'll get you to interpret. Year 11s, you don't need to interpret it yet. Okay, there'll be some other graphs that you'll learn to interpret, but not this level yet. Okay, so year 12s for your exams, that's the skill that you have to be able to do. You have to determine what shape of distribution is it. Is it a bit left? Is it a bit right? So is it right skewed, left skewed, centered, symmetric? And then explain what does that mean in context. That's when it gets hard. So in the short answer questions, that's what they get you to do. Okay? All right, team. That was your 5-number summary. So let's do one last example. Just flip over the page, and then I'll let you guys do your work. And I'll work with the year 12s just to make sure you guys know how to find materials, how to upload work as well. Let's just do the last bit, and the rest you can do it yourself. Here we go. Example 2. The following box and whisker plot shows the marks achieved by students on their end of year exam. So here's a box plot. Immediately, you should be able to see this is not symmetrical. Why is it not symmetrical? There's a huge tail end over here. And look at the box here. This is 25% here and then 25% here. It's slightly, the median has moved a bit to the right. And what that means is that because this represents students' score at the end of year, that means that the middle person of this data, they generally score higher. They're not just scoring at the middle of this group, they're a bit more skewed to the right. So this class, not only the middle person is scoring pretty high, the top quarter is also scoring pretty high. That's what this represents. But then that doesn't mean this lower end here means that maybe there was someone in this group that scored very low compared to everyone else. Okay, so that's it's right. It's left skewed, meaning on the left side it's a bit more skewed. It's pulled out. Okay, so here we go. State the median. Median's the middle line, so it's about what, 72 roughly. That's about 72, 71. Usually they have to have a more clearer mark, but we can do an estimate. It's about 72. Determine the interquartile range. Interquartile range is what, like Jasper said before, Q3 minus Q1. So the 75th position, take away the 50th position, or 25th position gives you 50% of the data. Q3 is right up here, roughly 88 maybe. And this one's about maybe 63, I reckon. Give or take. Okay, usually they have to give you a scale for you to count. Oh, sorry, you're right. 78. Thank you. 78. And so the distance between that's the group of people where most people sit. I want to know 50% of the data, what are they scoring between? 78 take away 63 is what? 7 plus 8, 15. So 78 take away 63 is about 15. This here tells me that there's a difference between the lower half, the middle of the lower half, to the middle of the upper half is only a difference of 15%. That's pretty good. Think about your maths class normally. So the person on the middle of the bottom half and the person on the upper half, the middle of the upper half, if you found the difference in scores, one kid could get 80 and the other kid 65. That's not bad. That's a pretty good, and that's what this data represents. This data, as you're looking at it, it clearly shows this class is doing better. The median's higher, and that's the interpretation. Obviously, you have someone, or maybe multiple people, who scored below 50, but overall, this class is a high-performing class. Okay? Last one, C, determine the highest mark in the class. Clearly, the highest mark is this value, the max, and it looks like it's roughly about 91, 92, somewhere there. And that's the interpretation of your 5-number summary. Okay, so 5-number summary, minimum, smallest number, Q1, Q2, Q3, so the quartiles, and then the maximum. Q1, Q2, Q3 is one of the most important data because it tells you the 50% of the population. Pav. Yeah. In the SAC, usually you guys make the, for 12s anyway, you guys do an investigation. So you create your box plot. And then I'll look at the box plot, whether it makes sense to what you're researching. It's the idea of being able to utilize 5-number summary, make a box plot, and then are you interpreting it right? That's what I'm looking at the year 12s, whereas for the year 11s, they're probably more likely to do something like this. So I'll have questions where I ask them, can you read the box plot? Can you draw a box plot? You know, those kind of things. So year 11's a skill, you guys interpretation. Yeah. All right, team, I'm going to stop the video there. Thank you for listening. And I'm going to walk over to the year 12s now. I'm going to show them how to upload. The rest of you, year 11s, you got the question sheet. You know which ones to